Hi, my name is Amber and I'm an educator here at Ripley's Aquarium of Canada. Today we'll be journeying to Planet Jellies, an out-of-this-world exhibit that houses one of our most mesmerizing underwater species. But before we dive deeper into today's topic, you may be wondering, what is a jelly and is it different from a jellyfish?
Sea jellies are gelatinous marine animals recognised by their umbrella-shaped bells and trailing tentacles. As a form of plankton, jellies are ocean drifters that ride the currents rather than swim against or with them. Surprisingly, these creatures do not have any blood, bones, brains, or teeth.
Although we commonly call them jellyfish, the term jellies is preferred because they are not fish.
At the aquarium, all our jellies have their own species-specific habitat. However, one species of jelly in particular can be seen either up close or above our heads, almost as if they are amongst the stars. Moon jellies, also known as common jellyfish or saucer jellies, can be found in temperate or tropical waters throughout the Atlantic, Indian and Pacific Oceans. They prefer to float freely along coastal habitats of northern Europe or eastern Canada.
So now that we've located their territories, how can we identify these otherworldly organisms?
Moon jellies can be recognised by the 4 horseshoe-shaped gonads that sit underneath their stomachs. Although sometimes they can have more or less of these reproductive organs. You can spot this here at the aquarium, for example, where some of our in-house jellies have 3 to 6 gonads. When fully mature, this species can grow to around 25 to 40 centimetres in diameter. However, rather than having a long trail of tentacles, these jellies have short, delicate tentacles that sweep food toward the edge of their bell. Thanks to their mostly translucent bells, they are virtually invisible to predators and prey as they can blend into the water. Alternatively, they have a skill of glowing in the dark. Bioluminescence, bio meaning life and luminescence meaning light, is the ability of a living organism to produce and emit light. This happens when luciferin, a light-creating compound, and oxygen react in the presence of the enzyme luciferase. Animals that can illuminate, like our serene species of moon jellies, may use this feature to communicate, attract mates, or confuse prey and predators. Although they can glow in nature, here at the aquarium, their rainbow of colours comes from the specialised lighting that illuminates their habitat.
But like all living creatures, these luminous invertebrates have to start from somewhere. Jellies have a 6-stage life cycle that begins as gametes drifting with the current.
These fertilised eggs will then hatch into larvae and continue to drift until they are cleared for landing. Larvae will attach themselves onto surfaces provided by the seafloor, such as rocks and shells, or even human-made surfaces like plastic or concrete. Once fixed in place, the larvae grow into polyps by sprouting tentacles to begin feeding upon plankton. At this point, they look like an extremely small and very cute anemone. Now comes the biggest change in a sea jelly life. The tentacled part of the polyp will separate, but remain on top, and the polyp will make a new tentacled part. These tentacled parts will stack on top of each other like a stack of pancakes. This creates a tower-like structure, which is called a strobila. Each of these segments are a clone of the original polyp. Strobilation is a great reproduction strategy, as the higher and larger the strobila tower, the greater the amount of offspring is likely to be produced, as the strobila splits into tiny genetically identical juvenile jellies called o-FISH-ially. Over time, the o-FISH-ially will mature into their adult stage, known as medusa. These will eventually release sperm or eggs into the water current to begin a new cycle of moon jellies. When you search for jellies online or see them in an aquarium, you are likely just looking at the medusa stage. However, here we showcase polyps, o-FISH-ially and medusa stages. This is a unique reproductive strategy employed by jellies. Their close relatives, coral and anemones, are only able to move with the current in their larval stage, and then can't move that far until they reproduce again.
Jellies are able to move as larvae and after strobilation, allowing them to travel far on the currents.
Creatures such as krill, larval shrimps and fish are the perfect meals for our carnivorous jellies. When an unsuspecting animal brushes against the jelly's tentacles, they come in contact with their stinging cells, called nematocysts. From there, a tiny sharp barb will burst out to pierce the prey and inject it with venom. Once stunned, the prey will be guided by the oral arms of the jelly to the underside of the bell. There, the four stomachs of the jelly will begin digestion.
Of course, jellies play an important role in ocean ecosystems. Not only do they control the population of plankton by eating them, but they are a food source for much larger animals.
Amongst their own kind, moon jellies are fed upon by the pink mealy jelly. Blue rockfish, anchovies and mackerel also enjoy consuming jellies, and they are commonly known for being a favourite snack of sea turtles. Sadly, because plastic enters the ocean at an alarming rate, this is directly affecting and threatening marine animals. To a sea turtle, a floating plastic bag looks like a tasty jelly, but once ingested, this can create blockages which can cause suffocation, starvation, and eventually death. Sea jellies, on the other hand, are threatened by microplastics, which are plastic particles. Microplastics can come from a wide range of sources, from large plastic waste degraded into smaller pieces, and small plastics manufactured for many products. As they are not able to biodegrade, microplastics will stay in environments once introduced, so they can be found in all environments, including freshwater, saltwater, marshland, and others. Jellies serve as an entry point for microplastics to enter the open ocean food web, as they can accidentally ingest these when hunting for food. This can happen either directly, by jellies mistaking microplastics for food, or indirectly, with microplastics already being present inside of the desired prey.
Microplastics and their smaller counterparts, nanoplastics, can often be found in drinking water. Due to their small size, they can pass through water filtration systems. Nanoplastics can also be found in the soil in which we grow our food and in the air we breathe.
But does this issue impact humans? Microplastics can be found in homes all across the world. One form to consider are microbeads, which are used in cosmetics such as exfoliants and facial cleansers. There have also been traces of microplastics in filtered, drinkable metropolitan water, as they are so small they can pass through filtration systems. So, if you're already a champion at putting your litter in the trash and using recyclables, keep it up. You could also inspire others around you to begin these great habits too by sharing your new jelly knowledge.
Thanks for watching this video, and I hope you enjoyed learning all this fin formation. If you feel like you're missing out on these beautiful creatures, don't be jelly. Come and visit them at Planet Jellies in Ripley's Aquarium of Canada. This is Amber, over and out.